Okay, last part of this chapter is 5-9. Okay, so we're working with fractional equations, continuing to work with those, but instead of having constants in our constants with a T, constants in our denominator, we're going to have actual variables in our denominator, which makes it just a little bit more difficult. So it's the same process. That's why we taught constants in the denominator first in 5-8. We're still going to multiply everything by the least common denominator. All right, both sides of the equation. But you got to check all the solutions and the original equation just to see if they work because of our denominators never being able to be equal 0. So if you do get a solution that works in the transformed equation, so that's the one that you multiply by the least common denominator, that's what we call the transformed equation, but it doesn't work in the original equation, that's called an extraneous root. So it's a root that works theoretically with the math, but you can't use it because it's not going to work in our original equation. Okay, so jumping into these quick examples. Number one here, okay, so like I said, the first thing you want to do is check to, or kind of put in the back of your mind from this original equation, what numbers for our variable would this not work? Okay, so when is the denominator going to be equal to 0? Well, for this one, it's only going to be at x equals 0. So we're just going to remember x equals 0, and if that pops up in our solution, we're going to need to address that. Okay, so we have to multiply this whole thing by the common denominator, which is 2x. Okay, so we multiply the first one by 2x, and you get 2. Second one by 2x, right? And you're going to get 1. Third one by 2x, you get 6x. So 2 minus 1 is 1. X equals 1/6. Okay, so this obviously works because it's not 0, so no problem. Perfect. Number 2 here. Got to multiply. Or first, let's think about what our extraneous roots might be. Well, they might be 1 or -1, because those are the two numbers for which y would make this denominator equal 0, and the whole thing blow up. So we got to keep those in mind. We're going to multiply by the common denominator. This common denominator is going to be y minus 1, y plus 1. Okay, we need to multiply everything by that. When we multiply the first one by that, the y minus 1s are going to go away. So we're just going to have 5 times y plus 1, which is 5y plus 5. For the second one, we've got a minus sign. So remember, this minus sign is going to have to distribute everywhere. Okay, so we're going to multiply. Our y plus 1s are going to go away. So we're going to have just 4 times y minus 1, or basically -4 times y minus 1. So we're going to have a minus 4y plus 4. And anything that's multiplied by 0 is equal to 0. So our answer will just be y equals -9. Now y equals -9 is not 1 or -1, so it is going to work. That's the answer. Last one here. Alright, we got to keep in mind 0 and -5. Those are the two numbers for which a would blow up the equation. And multiply everything by the common denominator, a times a plus 5. Okay, remember the way we find the common denominator is by just finding all the factors, multiplying them together. Okay, so when you multiply the first one by a times a plus 5, the a plus 5s are going to cancel each other out, and we're just left with a squared. And the second one, we're going to have a cancel out, and we're just going to be left with a minus 6 times a plus 5. FOIL that out, we'll get a squared equals a squared minus a, minus 6a plus 5a is minus a, minus 30. Okay, luckily our a squared is going to cancel each other out when you subtract them, and we're going to be left with a equals -30. Okay, and that's not 0 or -5, so we don't have any extraneous solutions. It's just -30. Okay, more examples. For this one right here, this is where things get a little bit more complicated, okay? So number 1 here, we're working with z minus 3, z squared minus 9, and z plus 3 as our denominators. We got to find the common denominators. Remember that to find common denominators, what we do is we have to factor all the denominators. Okay? Now, we don't really want our z minus 3 looking like that. Everything else has the variable in front, so what I'm going to do is I'm going to factor out a negative there. So I have z plus 3 over negative z minus 3. Alright, plus 11z plus 3 isn't going to change. And z squared minus 9 is the difference of two squares, so z plus 3, z minus 3. 1 minus 5z isn't going to change. And z plus 3 isn't going to change. Now here we can see that our common denominator, okay, is going to be negative, we need the negative, z plus 3, z minus 3. So we'll multiply this whole thing by negative z plus 3. That's an s, not a z. Okay, z plus 3, z minus 3. Distribute that everywhere. Alright, in this first one, the negative and the z minus 3 cancel out. We just have the z plus 3 squared, which we could just go ahead and do right away. Remember, z plus 3 squared is going to be z squared plus 6z plus 9. Okay, in the second one, the z plus 3 and the z minus 3 go away, so we just have to multiply the 11z plus 3 by negative 1, which gives us a negative 11z minus 3. And the last one, we need the negative, don't forget the negative, and the z plus 3's go away, we got to multiply by z minus 3. Okay, so this negative, what I'm going to do is I'm going to take this negative and just switch both of these two signs. Okay, so I'm going to do a 5z minus 1, right, from switching those signs, that negative's gone, times z minus 3. Now, we just have to solve for z. Oh, obviously, I forgot to take a look at the possible extraneous roots. We see here from the z plus 3 and the z minus 3 that it's going to be 3 and negative 3 are the dangerous ones we want to stay away from. So we have z squared plus 6z plus 9 minus 11z minus 3 isn't going to change. Foil out the right side here. We'll have 5z squared minus 15z minus 1z gives a minus 16z and a plus 3. Subtract everything over, get everything to one side, so we'll have a negative 4z squared. Okay, on this side we have plus 6z minus 11z is minus 5z. We're adding a 16z though, so minus 5 plus 16 is minus 9. Wait, minus 5. Oh, 11. Gosh, I can't even do math correctly. Whew! So we have a plus 11z, and 9 minus 3 is 6, minus a 3. Another 3 is a plus 3 equals 0. Now, we want to change all these signs because we don't want the negative at all in front of our 4z. So make that a plus. We get a minus 11z and minus 3. Now we got to try to factor. So factor this. Equals 0. Alright, so we're going to need a plus 3 and we're going to need a minus 3, sorry. Minus 3. A plus 1. We want the 4 to go there, and that works out perfectly. Now we solve this. So our solutions are going to be z equals 3 or negative 1/4. But remember that 3 can't be a solution because it's one of these extraneous roots. So that one's going to be gone, and the answer is just z equals negative 1/4. Well, like I said, one of the more difficult problems on here because you have to factor and all kinds of stuff. Alright, number 2. It's a little bit simpler. Okay, still pretty complicated, but remember that the x squared minus 4 is going to be an x plus 2x minus 2. Okay, so that tells us that our whole thing needs to be multiplied by x plus 2x minus 2. Okay. Now, we will distribute that everywhere. And x2 plus minus... Oh, we've got to remember our extraneous roots, right, are going to be x2 and minus 2. Okay. The x plus 2 and x minus 2 are all going to cancel out. We're just left with a 10. The 1 times x plus 2x minus 2 is just going to give us our difference 2 squares x squared minus 4. And when the x plus 2 cancels out for this last term, we're going to get negative x minus 2, so minus x plus 2. Alright, get everything to one side, solve for x. We'll have 0 equals x squared minus x. We have to subtract over a 10, so minus 12. And we can factor that to x minus 4, x plus 3. Okay, So the answers here are going to be x equals 4 and negative 3. Got to double check in the original equation. Are we going to have any extraneous roots? Nope, because it's not 2 or negative 2, so those are our two answers. Number 3. Alright, this one's very easy. Okay, hopefully you see right away. I'm not going to write it out, but x squared minus 1 is x plus 1, x minus 1. Okay, so that's going to be our common denominator. We got to look out for 1 and negative 1 because those are the times that our denominator is going to be equal to 0. Those are possible extraneous roots. We're multiplying by x plus 1, x minus 1. Okay, multiply it everywhere. When the x minus 1s go away, all right, we've got x plus 1 times 2x plus 3. All right, we got to FOIL that out. We're going to get 2x squared plus 3x plus 3x plus 2x is going to be a plus 5x plus 3. All right, the second one, the x plus 1s go away, and we've got minus 2x plus 3, right, because we got this negative, so it's a minus 2x and a plus 3 times x minus 1. So we'll have a negative 2x squared. We've got a plus 3x plus 2x, which is going to give us a plus 5x. And positive 3 times negative 1 is minus 3. And the last one, our x squared plus minus 1 is going to cancel out with our x plus 1, x minus 1. So we're just left with 10. Got to get everything together. Our 2x squareds cancel out. That's nice and lucky. Our 3 and negative 3 cancel out. Great. 10x equals 10. X equals 1. Okay? But remember that 1 is an extraneous solution because it can't be here. So that is going to be untrue, and the answer is just going to be no solution. Okay? Number 4. I made a small mistake here, so make sure you change this. Alright, it's not supposed to be a 3. It's supposed to be a 4 right there. Okay, this one's actually pretty easy, so we got to find, obviously, our possible zeros in the denominator is going to be 0, negative 1. We're going to multiply by our common denominator, which is x times x plus 1. Multiply that everywhere. Okay, our x's are going to cancel out. We'll be left with an x plus 1 in the first term. The x plus 1's cancel out, so we'll be left with a 4x in the second term. And x times x plus 1 times 6 gives us 6x squared plus 6x. Now, we got to get everything to the right to try to solve this quadratic. Alright, so 0 equals 6x squared. We're going to subtract a 5x off, so we'll be left with an x and minus 1. When we factor this, we know we're going to need a 2x and a 3x. And we're going to need a plus 1 minus 1. The plus needs to go with the 3, so it'll look just like that. Okay, so our two solutions here are going to be x equals negative 1/2 or positive 1/3. Neither of those are 0 or negative 1, so those are our solutions. And lastly, number 5. We see that x squared minus 9 factors to x plus 3x minus 3, so that makes this pretty easy. We know our roots, our extraneous roots might be 3 and negative 3. We're going to multiply this by an a minus 3, a plus 3. And things will start canceling out for us. So a minus 3's cancel out. We're left with an a plus 3 in the first term. Right, when we distribute, everything cancels out in the second term, so we're left with a plus 2. In the third term, we've got a 5a minus 15. Solve everything out here. We're going to get negative 4a equals negative 20. So a equals 5. That's it. I'll see you guys in class.